Alright, today we're going to do problem number 1 of homework number 9. Now, problem number 1 reads, suppose we have a stochastic process defined by W in terms of time variable t, such that the expected value of our W variable is equal to 0, and our autocorrelation in terms of W is going to basically be equal to the minimum of 2 time points t1, t2 times some constant alpha. Now, we now define another variable y in terms of time of t, such that it is basically the difference between w at t and w at t minus 1. So basically, it is a stochastic process at a given time point minus its value at the previous time point. It is defined for all values of t greater than or equal to 1, obviously, and 0 otherwise. Basically, what we're asked to do is find the E in terms of Y, so the expected value in terms of Y, as well as the autocorrelation in terms of Y. Finally, using these two terms, we have to state whether Y in terms of T is wide sense stationary, WSS. So, let's begin by just calculating with E what the expected value of Y of T is. So basically what we end up doing in this case is substituting in for y of t. So substituting in this function right here, what we get is e times w of t minus w at t minus 1. We can actually distribute the e value, so what we get is this term, the expected value of w at t minus the expected value of w at t minus 1. Given how we actually define the expected value of w at any time point is equal to 0, we can actually say this is going to be equal to 0, this is going to be equal to 0, so the whole thing is equal to 0. So our final answer is the expected value of yt is 0. Now, if we're going to calculate what our autocorrelation is in terms of y, what we're going to do is basically use the general definition. We're going to define, it's just basically y squared, all right, the expected value of y squared. So if we substitute that in at the 2 time points, we're going to use this right here, so w at t minus 1, at t sub 1 minus w at t sub 1 minus 1. That times the same thing at t2, so w at t sub 2 minus w at t2 minus 1. Now, if we actually break this down, we actually multiply it out, we're going to get this right here. And we can see the equation right here. It's going to be wt1 times wt2. It's going to be wt1 times wt2 minus 1 minus wt minus 1, t1 minus 1 times w at t2, written right there. And finally, plus w at t1 minus 1 times w at t2 minus 1. So we break that down accordingly. Then we actually distribute the e's, so we can actually look at the expected value of each of these terms, which we write down right here. So here we go. We're going to be looking at each term accordingly. Now, using our definition right here, we can see how each one of these terms is just basically an autocorrelation at different time points. This is going to be an autocorrelation at time points t1 and t2. This is going to be an autocorrelation, all these are in terms of w. It's going to be an autocorrelation at t1 and t2 minus 1, autocorrelation at t2 and t1 minus 1, an autocorrelation at t1 minus 1, t2 minus 1. So basically, we can actually break this down accordingly and write it like here, as follows. And since we actually define the autocorrelation of w like this, basically alpha times the min of the 2 time points, we actually can write it out. We bring out the alpha value because it's going to be distributed across each term. This term right here is going to be equal to alpha, the min of these 2 time points, minus, and you can see how this is going to be the min of these 2 time points. These two terms correlate, the min of these 2 time points, the min of these 10 time points. So that's our generic equation for the autocorrelation, a big R in terms of y. Now, This term is going to take on different values depending on actually how T1 and T2 are related to one another. Okay? Now, T1 and T2, the way, if you think about it, the only ways they can be related to one another is T1 is either going to be less than T2 or T1 is going to be greater than T2. All right? So, but we can define it even further than that, because let's suppose T1 is less than T2. Then the question that becomes that what about the term T2 minus 1? All right? Is that going to be less than T1, or is it going to be greater than T1? All right? We can actually go that route. Could also say the other way. But if we could actually say the other way and think about, well, T1 minus 1 versus T2, well, that's going to be always less than still. It's not going to change. If you subtract anything from the smaller value, it's not going to change the relationship. T2 is still going to be greater than T1, T1 minus 1, etc. So the only way we're actually going to have to look at this is basically how the two are related and what happens when you subtract 1 from the greater value and how it relates to the smaller t. So if we actually think this out, we end up with 4 different scenarios that need to be considered when actually solving for our autocorrelation in terms of y. Those scenarios are as follows. Supposing that T1 is less than T2, and what happens when T2 minus 1 is less than T1? All right? The counterpart to this is scenario 2, when, again, T1 is less than T2, but what if T2 minus 1 is greater than T1? All right? Notice how these terms can actually be rearranged, so we can actually show that what happens if this term basically equates to what if the difference is less than 1, and in scenario 2, what happens if the difference between the 2 time points is greater than 1. Then scenarios 3 and 4 are very similar, except instead of having T1 less than T2, we have T1 greater than T2 in both scenarios 3 and 4. And again, what we're looking at is like, okay, if T1 is the greater value, there's a scenario where T1 minus 1 is going to be less than T2, and that's going to be basically equal to the difference being less than 1. And what happens when T1 minus 1 is greater than T2? And that's going to be equal to the difference of the 2 time points being greater than 1. So what we have to do is look at each of these scenarios and see how this term right here breaks down in each of those scenarios. So here are the 4 scenarios right here. Okay? And we're going to try to take them one at a time, but I don't want to belabor the point too much. I specifically will look at the first 2. So, in this equation right here, let's say T1 less than T2, and then as I said, T2 minus 1 is less than T1. What that ends up being is, again, alpha on the outside. By this definition, this term is going to be T1. Makes sense. Okay? This right here, by this definition right here, T2 minus 1 is going to be the lesser value. So these two correlate. Then this right here, as I explained, if T1 is less than T2, then T1 minus 1 is still going to be less than T2. So that's going to, these two correlate right here. That's the answer. And then subtracting 1 from both sides isn't going to change the correlation between these two. So T1 minus 1 is going to be less than T2 minus 1. So this term correlates to that. These two terms we can see cancel each other out. So this is going to be T1 minus T2 plus 1. That's how it breaks down. Now, just for, I wanted to rearrange the terms because as you see in scenario 1, I liked how we were looking at the difference being less than 1. So I wanted to write it in terms of T2 minus T1 as if this is a difference term. I want everything written in, or at least for scenario 1. So I rewrote this and just wrote it as 1 minus this difference. Okay, so that's scenario 1. Scenario 2 is going to be very similar. All right. The only each of these terms right here are going to be the same, as you can see. The only difference, because of this definition right here, is going to be that the T1 is going to be the smaller value versus T2 minus 1. So we substitute in T1 here, while over here we have T2 minus 1. As we can see, these two terms cancel out. These two terms cancel out. Alpha times 0 is equal to 0. So this is going to be equal to 0. Now, Scenarios 3 and 4, I don't want to get into too much, but it's very similar. They're like mirrors of one another. The only difference here is that, okay, if T2 is going to be the smaller value, all right, so our first term is going to correlate to T2 in scenario 3, all right. This term right here, because T2 is the smaller value, subtracting the 1, still going to be T2 minus 1 is going to be less than T1. This term right here, because of this definition, is going to make T1 minus 1 smaller than T2. So that correlates to that. And again, because subtracting 1 from both sides doesn't make a difference, it's going to make it so T2 minus 2 is less than T1 minus 2. T1 minus 1. Sorry, I misspoke there. T2 minus 1 is going to be less than T1 minus 1. Anyway, these two terms cancel out. We bring it over. We can actually show again that this term can be written as an alpha times 1 minus the difference between these two terms, the positive difference, because, again, T1 is the greater value. This is going to be a positive difference. This is going to be a positive. In fact, these two terms are going to be identical to another given the scenarios here. All right? Again, this term right here, the only difference between these two terms right here is going to be in the third term. While right here, the T1 minus 1 term is the smaller one. In this case, the T2 term is going to be the smaller one. T2 terms cancel. T2 minus 1 terms cancel. This ends up being 0. So the entire breakdown can be written as follows. The autocorrelation in terms of y. If you look here, basically the only terms when it's not 0 is when the difference is between T2 and T1, T1 and T2, however you want to arrange. When the absolute value of this is less than 1, here in scenario 1 and scenario 3, we can actually define the term. All right? Otherwise, it's going to be equal to 0 when the difference, the absolute value difference, is greater than 1. And we basically write that out as such right here. So it's going to be equal to, it's equal to these terms. It's alpha times 1 minus the absolute value of the difference between these two time points. All right? And that's for basically when the absolute value of the difference is less than or equal to 1. Otherwise, if this difference, the absolute value, is greater than 1, as you can see in scenarios 2 and 4, the value is going to be equal to 0. Also, if you wanted to, we can rewrite this difference in terms of some sort of generic tau value. If we define tau as equal to the difference between 1 and 2, let's say 2 and 1, we can basically write this as alpha times the difference between 1 minus the absolute value of tau for points where the absolute value of tau is less than or equal to 1 and 0 otherwise. So that's our answer for the autocorrelation in terms of y. And finally, as you can see, because we can see that the expected value in terms of y is equal to a constant of 0, and because we can write our y in terms of the time variable t, that indeed the function y of t is WSS. Thus ends problem number 1 of homework number 9.